In the second function, we've got to graph two full cycles of negative 2.7 sine of 0.9 times x plus 50, and then add 2.2 to that. And again, I'm going to relate it to the a, b, c, and d parameters. So there's my a parameter. A is equal to negative 2.7, which tells me that there's going to be a reflection along the horizontal axes because a is less than 0. It's a negative 2.7, and then we have a b coefficient of 0.9 that controls your period, the length of one cycle. The c value controls the phase shift. Remember that this is going to control the phase shift, or whether it shifts to the right or to the left. So c controls the phase shift, and d controls the up-down shift. So that's called a vertical shift. So what this tells us is that the whole shooting match is going to be shifted upwards by 2.2 units. So what am I going to relate it to? I'm going to relate it to the original function. I'm going to relate it to y is equal to sine of x. What do I know about sine of x? Everybody should know this about sine of x. We should all know that the length of sine of x is 2 pi radians, or 360 degrees, and it starts at 0, 0, and ends at 0, 360 degrees and 0. And so halfway between 360 degrees is 180. That's half of a cycle, and for half of the cycle it does the top half, and for the second half of the cycle it does the bottom half. So there's your sine curve. So this is y is equal to sine of x, and of course we aren't going to be shifting exactly y is equal to sine of x. It's going to be y is equal to minus sine of x. So remember, so we're going to reflect this whole shoot and match. So instead of doing the up first and then following it with the down or the lower portion, we're going to start with the, we're going to reflect it, and it's going to be reflected on the bottom side, and then we'll do the top side. So this is y is equal to negative sine of x. So our curve will resemble a transformation of y is equal to negative sine of x. First thing that we're going to deal with is the amplitude. Our amplitude for our new function is going to be equal to 2.7. And so since the amplitude is equal to 2.7, it's not going to go from minus 1 to positive 1. It's going to go from minus 2.7 to positive 2.7. And that would be where I would stop, except for the fact that I've got to deal with this vertical shift as well. So in order to deal with a vertical shift, I'm going to recognize that it has to be shifted upwards by 2.2 units. So the minimum is going to be moved upwards by 2.2 units, as is the maximum. The maximum will be up higher by 2.2 units. So my minimum value in my range is going to be minus 2.7 plus 2.2, which is equal to minus 0.5, and the maximum value will be equal to 2.7 plus 2.2, which is equal to 4.9. So now I know my channel. My channel of values, minimum to maximum, is going to be from minus 0.5 to 0 to 4.9. Next question that I have to ask myself is, how long is one cycle? How am I going to deal with the cycle length? The length of the cycle is going to be controlled entirely by the b coefficient. So for a normal sine curve, the cycle length is 360 degrees. So I'm going to take that 360 degrees and I'm going to divide it by the b value. The b value controls the length of the cycle. So I'm going to divide that by 0.9. And 360 degrees divided by 0.9 works out to be 400 degrees. And that means that for one cycle I'm going to need 400 degrees in my graph. For 2 cycles I'm going to need a total of 800 degrees in my graph. But one more thing that we need to factor in, and that is the fact that there is a phase shift. So there's a shift of 50 degrees. And which way is that 50 degrees shifted? Well, that 50 degrees is shifted to the left. So c is equal to plus 50, which means that it shifted 50 degrees to the left. So our graph is going to start at minus 50 degrees. And where is the cycle going to end? It's going to end 400 degrees later. So minus 50 degrees plus 450 degrees will take me to 350 degrees. That's going to be the length of one cycle. Now I have to take it one more cycle yet. So 350 degrees plus one more cycle means 350 degrees plus 400. So then the next cycle is going to end at 350 plus 400, or 750 degrees. So there's your 2 cycle lengths. Are you ready for the graph? So here's our x-axis and our y-axis. We know that it's the channel of values is going to be from minus 0.5 to positive 4.9. So we've got, let's just see, minus 0.5 to positive 4.9. I'm not doing this very properly. I'm not using any scale factor, but I know that minus 0.5 is below the x-axis and 4.9 is above the x-axis. So there's my range of values. So the range, my channel of values, is going to be inside this range. Where's the midpoint? Where's the mid-range? Well, all you have to do is add those two numbers together, and 4.9 plus negative 0.5, add those two up together and divide them evenly by 2, and you're going to get the mid-range. And the mid-range will give us the middle of the channel of values. Or in other words, if I folded the paper in half with the minimum meeting the maximum, then I will get the mid-range. Well, what do you think the mid-range is? When you add those two numbers up and divide it by 2, you're going to get y is equal to 2.2, which is my d value. That's the shift upwards. So this is y is equal to 4.9, that's the maximum, and y is equal to negative 0.5, that's my minimum value. Well, now I know that the range of values is from negative 0.5 to 4.9, and so now I'm going to deal with the length of the cycle. So what did we say that our cycle was going to start at? We said it was going to start at minus 50 degrees. So minus 50 degrees is right here. So minus 50 degrees. And then I have that cycle is going to end at positive 350, because a cycle is 400 degrees long. So from minus 50 to positive 350 is one full cycle, and the next cycle is going to end at 350 plus another 400. That's going to take me over to 750 degrees. So what do I know? I'm going to start plotting some points here. So it's at 0. Remember that the sine curve starts at 0, 0. So instead of starting along the x-axis, it's going to start a little bit higher, 2.2 units higher. And again, it's going to meet up at the axes. So this middle value is similar to our x-axis, but it's shifted upwards, and there's our next 0 point. And so now I have to come up with my other points, my other critical points for my curve or my function. So for sine curve, again, we know that it has a maximum. Maximum is up here, but however, and it's halfway between these 2 points of negative 50 and 350, but it doesn't go in a positive direction. It starts off in a negative direction, so therefore it's going to go down here. So it's going to go to a minimum value, then it's going to go to a maximum value, because remember it's negative 2.7 multiplied by the sine function. So it's going to go down to the minimum value, back up again, and then, whoops, I goofed. Wow, did I ever goof? That's not a full cycle at all. I need to go back up here and finish this in, because one full cycle is 400 degrees. Remember, 400 degrees is a cycle here, and I jumped the gun here. So 400 degrees is another cycle. And so let's fix this up. So what happens is it finishes here, but I need to go down and then, whoops, I have to go all the way down to the minimum value and then up to the maximum value. And that's my full cycle. And then again, I need to go to the midpoint, halfway between 350 and 750, go down to the minimum value, and then up to the maximum value. And so my curve, let's draw it again with red to make it stand out here. So minimum and maximum, and that's my one cycle. Minimum, maximum, one cycle. Down to the minimum, which is minus 0.5, back up to the maximum. And again, this maximum point, by the way, is exactly halfway between these two values here. So we divide that up into sections, starting off with the length of the cycle first. So that 400 degrees is a cycle, so this is going to be 200 degrees, and that's also going to be 200 degrees. So this is going to end at 150 degrees. It's just use common sense here. So each one of these is going to be 200 degrees long. And now what I'd like to do is I'd like to go back and show you what my graphing software generated for you. And this is, by the way, this can be found on desmos.com. Desmos.com, great little website which you can go to and you can graph any function, and you can see that the blue curve is your sine curve. This is the original sine curve right here. Original sine curve. I didn't bother to put any special points here, but you can see there's our points for our minimum, our maximum points and our minimum points for our transformed function. And you can see it starts at minus 150. Minus 50 degrees would be about here. So there's our where we're going to start, and there's our mid-range right there at y is equal to 2.2. So we've plotted those points. Okay.